All right, everybody, welcome. Today, we are going on the ultimate road trip. We're going to take an intimate, cosmic tour of our home, this spectacular, sprawling city of stars we call the Milky Way. So, just imagine for a second. What if you could hop in a spaceship and just, see it all? What if you could cruise down the spiral arms, check out the glowing core, and get that perfect bird's eye view of our entire galactic home? I mean, sounds amazing, right? Well, yeah. There's a pretty big catch. You see, we can't just fly outside the Milky Way to snap a quick picture. We're already in it, looking out. And that, right there, makes getting a complete map of our own home, well, it's incredibly tricky. And I love this analogy because it perfectly captures the problem. It's like trying to map a huge forest while you're standing right in the middle of the thickest part. You're surrounded by trees, or in our case, stars, gas, and dust that are blocking your view. So to understand the whole forest, we have to piece together all these little clues from our tiny clearing. Okay, so for our first stop on this grand tour, let's pull up the blueprint. Let's ask the big question. How is our galaxy actually put together? We're going to look at the grand architecture of our cosmic home. The Milky Way isn't just some random blob of stars floating around. Nope, it has a very specific classification. We live in what's called a barred spiral galaxy. And the key feature, the thing that gives it its name, is that dense, bright, bar-shaped structure right there in the middle, with those iconic spiral arms branching off from the ends. And here are the main components, broken down. First, you've got the flat disk. That's where we live, and it's got all the bright spiral arms. Then there's that central bar we just talked about. Now, surrounding all of that is the stellar halo, which is this kind of ghostly sphere of really old stars. And then, holding the whole thing together, is the mysterious, totally invisible, dark matter halo. Okay, let's talk scale for a second, because this is where your mind is going to start to bend a little. To get from one side of the galactic disk to the other, you'd have to travel for 100,000 years at the speed of light. I mean, think about that. Nothing we know can go faster, and even at that ultimate speed limit, the trip would take longer than all of recorded human history combined. It's just staggering. But wait, here's the kicker. Even though it's 100,000 light years across, the disk is only about 1,000 light years thick. The analogy they use is perfect. Imagine two CDs stacked on top of each other. That's the ratio. That's how incredibly flat our galaxy is. It's unbelievably wide, but totally razor thin. All right, so we've got the city layout down. Now, let's move on to our next stop and meet the citizens. We're going to take a census of the stars, all those hundreds of billions of residents that call the Milky Way home. Okay, now what's super interesting here is that not all stars are created equal. Astronomers actually group them into different populations. On one hand, you've got population I stars. Think of our sun. They're young, they're rich in heavy elements, which, by the way, astronomers call metals, and that's just anything heavier than hydrogen and helium. These stars orbit nice and orderly in the galactic disk. But then you have population II stars. These are the galaxy's senior citizens. They're ancient, they don't have a lot of those metals, and their orbits are totally wild and eccentric out in the stellar halo. They're basically fossils from when the galaxy was first forming. And here's why that matters to you. This isn't just some abstract astronomy lesson. See, those metals in the younger stars, like our sun, they came from the ashes of older stars that blew up in supernovas. The iron that's in your blood right now, the calcium in your bones, every bit of it was forged inside a star billions of years ago. We are literally made of stardust. It's cosmic recycling. All right, everybody, buckle up. Seriously. For our next destination, we are heading to the most violent, chaotic, and absolutely fascinating place in the entire galaxy, the very center. For centuries, the galactic core was just a mystery. It's a place so jam-packed with stars and hidden behind such thick clouds of dust that our normal telescopes couldn't see a thing. It was just a blank spot. But then we built instruments that could see in infrared and X-ray light. We finally peered through that veil, and we found a monster waiting for us in the dark. And there it is. Meet Sagittarius A star, or SGR for short. This is the supermassive black hole that acts as the gravitational anchor for our entire galaxy. It's the silent, invisible ruler sitting at the very heart of our cosmic city. So, you hear supermassive, and you wonder, how super is it really? Well, Sagittarius A star packs the mass of, get this, 4 million of our suns into a single point in space. 4 million. That's the gravitational engine that's driving our entire galaxy. Everything, every single star, every planet, including us, is locked in this slow cosmic dance, orbiting this one invisible behemoth. Okay, for our final stop, we're going off the map. We're venturing into the unknown. Because despite everything we've figured out, our map of the Milky Way still has these huge blank spots. You know the old school maps that said pure be dragons? These are the great galactic enigmas that scientists are still trying to solve right now. So here's one of the biggest questions in all of science, really. When you look at the stars on the outer edges of our galaxy, they're spinning way too fast. Based on all the stuff we can see, all the stars, the gas, the dust, there just isn't enough gravity to hold on to them. They should just fly off into space. So what's going on? What's holding it all together? The answer, or at least the best one we have, is something called dark matter. Think of it like an invisible, ghostly scaffolding that makes up most of the galaxy's mass. We can't see it, we can't touch it, we have no idea what it is, but we know it has to be there, providing the extra gravitational glue that keeps our galaxy from flying apart. And that brings us to maybe the most profound puzzle of all. Look, our galaxy has hundreds of billions of stars. We now know it probably has even more planets. Just by the sheer odds, it seems like intelligent life should have popped up somewhere else, right? So, where is everybody? This, my friends, is the famous Fermi Paradox. It's this huge contradiction. In a galaxy so vast and so ancient, why is everything so quiet? Are we really alone? Or maybe, are advanced civilizations out there just deliberately staying silent? Or is it possible that complex life like us is just way, way rarer than we ever imagined? It's one of the most haunting, fascinating questions you can ask, and it's all happening right here, in our own backyard. And I think I want to end our little tour on this thought. When you study the Milky Way, you're not just studying space. You're studying our own origin story. Our very existence is completely tied to the life cycle of this galaxy. That faint band of light you might see in the night sky, that isn't just something pretty to look at. It's our context, it's our heritage, it's our home. And the journey to truly understand it, well, that has only just begun.